start here, I want to thank Dr. Patrick Marsh for joining us today and doing this. Dr. Marsh is from Fort Smith, Arkansas. He graduated with his BS in mathematics and physics from the University of Arkansas in Fayetteville in 2005. Then went on to Oklahoma from 2005 to 2013, where he got a master's in 2007 and a PhD in 2013. His dissertation work was on statistical techniques for calibrating numerical forecasts of rare events. He's been with the Storm Prediction Center since 2013 as a techniques development meteorologist, and then in 2016 was promoted to warning coordination meteorologist until 2019, where he is now serving as the chief of the science and support branch. And so currently he's overseeing the extremely talented individuals tasked with executing SPC's research and technology portfolios. And the portfolio includes, but is not limited to, the development of new forecast guidance, the SPC transition from NAWIPS over to AWIPS, and the infrastructure that runs all of that. So thank you, Dr. Marsh, again for joining us. And with that, I will bring it over to you.
All right, thank you. So we'll get started here. The title of the talk that I chose to put on the slide is SPC 20XX, and it's intentional because what I'm going to kind of lay out here is some vision of where SPC and more broadly, or basically where SPC wants to go within the broader vision of NOAA and the National Weather Service and embracing facets and the like. And so I don't necessarily know when all these components will be officially operationalized. This is kind of more of a vision of where we're going. So it's hopefully it'll be in sometime before the year 2100 so that the title will work. So we'll kick off the SPC 20XX presentation. But first, I thought I'd give a little bit more about me, more than just the traditional intro. Hopefully, it'll kind of motivate some people out there to know that you can be a total a screw up as a student and still go on to be somewhat successful within with your career and the like. So the real fun thing, and the thing that I get teased a lot about here at the Storm Prediction Center, is in the third grade I wrote that I wanted to be the director of the National Severe Storms Forecast Center. That's the predecessor to what is now known as the Storm Prediction Center. And so even as a young age, I've always been interested in severe storms and the like. In third grade, and I'll embarrass myself with showing a picture of me from high school, I wrote in a local almanac in the Fort Smith area that I wanted to become the head of the Storm Prediction Center or the National Severe Storms Laboratory. So again, between third grade and 11th grade, I still wanted to go along that path. But then I went to college and nearly failed out after my freshman year, and I use failed out in quotes because basically it was the first time away from home, and I had been one of these kids in high school that was never really challenged, and got out to college and not under parent supervision, and was introduced to the world of Super Mario Smash Brothers, and decided that I didn't need to go to class. And after the first year, my GPA was such that I had to go to summer school to get my GPA back up, or they were going to take away my scholarships. After my sophomore year, trying to outdo my freshman year, in my spring semester, I got a 48 on a take-home physics exam in the class called Analytical Mechanics. And I was like, whoa, this is really hard. This isn't for me. I want to go be a meteorologist. I don't want to be I don't want to do physics or math anymore. So I'm gonna transfer. And I had a come to Jesus moment with the professor of the class. And he sat down and talked to me and basically convinced me that getting a degree in physics is not anything about learning physics. It's actually more about learning how to think critically and think like a scientist. And I don't know what it was about that conversation, but it kind of clicked with me. Went on, finished off my undergrad, applied to graduate school at both the University of Arkansas for a master's in physics, and then also at the University of Oklahoma for a master's in meteorology. Regarding OU, I was, quote, accepted, then, quote, rejected, then accepted, but I declined because I didn't like how I was accepted and then rejected before. Then my wife basically said, well, or my fiance at the time, my now wife, basically said, well, I'm going to go to University of Oklahoma for graduate school, so you can either stay here by yourself or you can come with me. So I begrudgingly accepted admission to OU School of Meteorology, went on to graduate school, and ultimately graduated with the PhD. So I'm very thankful to her for not letting my pride get in the way of what ultimately was what I wanted to do in the best part of my life in getting into the weather service. So without her, I probably am not sitting on this call right now. All right, so my PhD was in statistics, statistical calibration. So I have to go start with this probability theory icebreaker. And if you've seen any of my talks, you might have seen this before. But for those of you who might be viewing in a group setting, the question is, do two or more people in a room share the same birthday? And for the less probabilistically or statistically inclined, when they hear this question, they often think that, oh, well, you have to have a lot of people in a room, like what, 150, 200 people in a room before you really have a high chance of having the same number of people with the same birthday. But in reality, when you do the math and you start solving the statistics problem, it actually comes out that when you have about 22 and a half or 23 people in a room, the probability of two or more people in that room sharing the same birthday is actually around 50%. And by the time you get to about 50 people in a room, you're well over 90% likely to have two or more people in the room with the same birthday. And so this kind of gets at this notion of, even though as meteorologists, a lot of what we do stems from understanding and utilizing probabilities in statistics hard. And when we do probabilistic forecasts, at least at the Storm Prediction Center, we've got a saying, all forecasts are wrong, but some can be useful. And what kind of gets at that is, you can be right in some areas, you can be wrong in others. What does it mean to have a correct probabilistic forecast? You can have a 10% probabilistic forecast and it be correct, and an event could occur, but people may think it's wrong. So this whole notion of thinking probabilistically is integral to what we do as a discipline, and it's crucial to everything we do here at the Storm Prediction Center. And so, to reiterate this, oftentimes you're faced with a situation where the weather forecast calls for 50%, or if you're actually making the forecast, you're like, well, everything that I've looked at suggests that there's a 50% chance of rain tomorrow. And at least when you interact with the public, or you're dealing with some end users, what you tend to see is people say that the meteorologist is just guessing. And so the question I have is, are we just guessing, or is there useful information in the forecast? And in some iterations of going through this, I'll go through a whole spiel of using SPC forecast to ultimately show that we're not just guessing, that a 50% probability is actually incredibly useful. But in the context of rain, where people think that the decision is yes, no, there will be rain tomorrow, they think, well, 50%, you're just guessing. But in meteorology, and actually in statistics, the guess answer, the answer that you give if you have no additional information, is actually the climatology of the event. And so what happens is, most people, when they're presented with two options, they think the climatology of those two options is 50-50, equal parts. And because whether or not they realize it, at least my interactions and my experiences, most people default back to this thought of flipping a coin. The climatology of heads is 50%, and the climatology of tails is 50%. But in meteorology, the climatology of yes, no for rain is somewhere closer for most locations, down around 10%. So if a forecast calls for a 50% chance of rain, what the forecast is implicitly saying is there's a 5 times greater chance of rain today than on normal. So if you phrase the question in that way, you're 5 times more likely to see rain tomorrow than normal. Is there useful information in that? And most people, when they stop and think about the problem that way, they actually get it and say, well, yes, there is a lot of information contained in that. However, when I talk and I give this example in this thought experiment to broadcast meteorologists, often they tell me, it doesn't matter, my news director still says I can't ever use 50%, so maybe you should go give this presentation to him. And so if there's any broadcast meteorologists on the call, sure, I'll go through this thought experiment with your news director, but I know that it's probably not going to change the minds of what the consultants say. So why have I spent so much time talking about probability and statistics? And the reason for that is in meteorology, the atmosphere is inherently chaotic. And so the only way you can properly describe the chaotic nature of the atmosphere is to embrace probabilities and to communicate scenarios in a probabilistic framework. And so at the bottom of this slide, you'll see 2 double pendulums that are swinging, and their initial conditions, they're offset just ever so slightly. Visually, it's imperceptible. But as you go through the integrating the equation of motion for a double pendulum forward, you can see that it doesn't take very long before you end up with completely different solutions for where the location of the double pendulum actually is. And to reiterate that one more time, here's the example with a triple pendulum. So we're adding a little bit more complexity to the problem. And on the left, this is just a single integration. You can go forward because we know the equations of motion for a triple pendulum exactly. You can solve it and know exactly for any t for any time where the pendulum will be. On the right, let's take 10 triple pendulums, and we're going to stack them on top and perturb their initial condition ever so slightly, so visually you can't necessarily see it. And so what you'll see here is as we animate forward, at least initially, you can see very little, you can't see the differences, but it doesn't take long for those very imperceptible initial condition uncertainty at the starting point to integrate up and compound into much bigger errors, such that by the end of the animation here, you essentially have complete chaos. And because we know the governing equations of motion for the atmosphere, but the problem is we don't know the initial condition or the initial starting point, the t equals 0 for every molecule in the atmosphere, which is what we would need to be able to perfectly predict what's going to happen forward. So instead, what we do is we use ensembles and we use probabilities to try to communicate the uncertainty associated with the error from the initial conditions. Now, using numerical models, we also have additional terms of uncertainty stemming from the parameterization schemes and the fact that we're not going to explicitly resolve all the scales of motion because of the computational expense. And so that's an additional error of uncertainty as well. And so the idea is because all these uncertainties compound as you integrate forward in time, the only proper way to describe, to make a true forecast or a proper forecast is to do so probabilistically. And there's a lot of body of work that in the scientific literature that you can read to get a comprehensive understanding about why we, as meteorologists, have to embrace probabilities moving forward. Here at the Storm Prediction Center, probabilities are central to all of our forecasts, and based on that, it's actually inherent and explicitly linked to how we do our communication. So our communication is fundamentally linked to the underlying forecast probabilities. And essentially what we try to do is we're building and moving towards building 3 distinct forecast layers. Probabilistic weather hazard risk quantification, it's a fancy way of saying the actual forecasts themselves. Probabilistic impacts of the forecast, and that's the risk quantification, or in other words, the translation of the forecast into potential impacts. And then also how we communicate our forecast to the public is also linked to the underlying probabilities. And we do that so that when we enter a certain weather event, we know that we're going to respond and act the same way. Our communication posture won't change based on what day of the week it is. You know that our partners know that if we're going to forecast a moderate risk for tornadoes, which is at least a 15% risk of tornadoes with at least a 10% probability of significant tornadoes, that equates to a moderate risk. You know that every time we forecast that, our communication and our communication posture and cadence is going to remain the same. And all of this ties back to the probabilistic forecast and is derived from the probabilistic forecast. In our current forecast and warning paradigm or continuum, it's basically a continuum from days, from at least in the Storm Prediction Center, all the way down to minutes to the actual event itself. And we've the process that's been developed to address the conveying and cadence of information to our partners is the outlooks, which span days in advance up to the current day, down to the convective watches, severe thunderstorm or tornado watches, which are typically on the scale of hours, down to warnings, which is on the scale of minutes to maybe up to an hour, down to the event itself. And as you move down this paradigm, ideally, your uncertainty begins to decrease, but at least in practice, what I have experienced is uncertainty begins to decrease up to a certain point, and then as you go for the last mile into the event itself, the uncertainty tends to start to increase again. So maybe the decreasing uncertainty that we feel, or at least for me personally, that I feel leading up to an event, it's probably false certainty that I am experiencing. But anyway, in the current forecast and warning continuum that we currently experience and utilize, there's a big information void between the outlook and the watch. And if we're going to go forward towards facets, and hopefully everybody on the call or listening to this at a later date is aware of facets, but if the Weather Service is going to completely embrace facets, we have to move towards a true continuum of information, which means at the Storm Prediction Center, we need to begin to fill the void between the outlook and the watch scale. And that's kind of what we've been doing in-house. And over the next few years, you'll begin to see some of what we're doing begin to become more public-facing and available to all of our partners in an official capacity. Here's a slide that I put in here so that if you want to go back afterwards, you can see it. But this is kind of what the vision of facets is supposedly supposed to enable within the Weather Service. And SPC is trying to touch on all of these bullets. First and foremost, as I mentioned, our SPC embraces the probabilistic forecast paradigm. All of our forecasts are inherently probabilistic in nature. And this is our verification of these probabilities. It's actually very reliable. We have a slight under forecast, but generally speaking, it's good to see that as we forecast higher probabilities, the frequency of those events actually occurring is also increasing as well. And it's roughly a linear increase, which is what you would want to see. And in fact, if you go down to our day one probabilistic outlooks of all tornadoes versus EF1 or stronger tornadoes, you actually see that we have an over forecast, we have a bigger under forecast of forecasting all tornadoes. But if you limit it to the EF1 or stronger tornadoes, we're much closer to the reliability line of saying basically, and it's a way of saying that if we forecast a 40% of the area, 40% of the time something occurs, and that's the gray line that goes from the bottom left to the upper right of the plots. And we also do our probabilistic forecast on days 2 and 3, and so you'll actually begin to you can see that our forecasts are also quite reliable out into the future as well. Now this day 2 is actually going to change tomorrow, where our day 2 probabilistic forecasts are actually going to become identical to our day 1 probabilistic forecasts. In other words, we're actually going to split out, instead of having a total severe probability, we're actually going to begin to explicitly forecast the probabilities of tornado, wind, and hail. And that transition should be tomorrow morning before the day 2 update, so basically before 1730Z. How do we do a probabilistic forecast? Well, we make use of probabilistic forecast tools. We embrace storm scale ensembles quite a lot. We use that to pull out probabilistic information, but we also do it at different scales. We use the SREF, the HER, I already mentioned the HREF. But one of the nice things here is it's not just 24-hour static stuff or full period static. You can actually get animations from the high-res guidance of probabilistic information that's calibrated. And so that's some of the work that we're doing here at the Storm Prediction Center. So here's an example from, I believe this is this 2018. This is what ultimately ended up being a moderate risk tornado hit Jackson's, I believe it was Jackson State, or at least it hit a university in Alabama, caused extensive damage. But you can see the high-res models provide some sort of temporal aspect to the forecast. And so what you're seeing is you can take this high-res guidance, and what we're doing, I should say, you can take this high-res guidance and combine it with the expert human forecast. And what we're doing is, when you combine the two, you can actually take the expert human forecast and break it out into time periods at scales below the full 24-hour forecast period, which is what the SPC forecast traditionally has been. And so you begin to get a temporal aspect of when the severe weather may threaten any individual point. And so this idea is, if we can provide more timing information, we can start to provide better product and services that might fill the gap between the outlook and the watch. For example, one of the things that you can see that can be derived from this timing information is the figure on the right, this earliest reasonable time of slight risk probabilities. This is an SPC attempt to try to mimic what you might have seen recently from the Hurricane Center with their earliest onset of tropical storm force winds or earliest onset of hurricane winds. This is something akin to that using severe, where you take the human forecast and you combine it with all of the calibrated probabilistic guidance that's available, and you can begin to provide some of this timing information as well. You can take it a step farther, and you can click on an individual point and see your risk evolve through time. On this particular day, you can see that the risk for tornadoes peaked out at around 15%, which is a moderate risk, hence the red shading in the background. But you can also see we've illustrated on the bottom of this figure where when the SPC tornado watch was in effect. And then you can see at the very bottom, there was an EF3 tornado in Columbus, Mississippi that occurred well within where this temporal disaggregated forecast or the enhanced timing information forecast, it fell very near the peak of what we were saying is your peak threat. As you do the first slide that I showed here, this is based on our 13Z forecast, so the forecast early in the morning. But then if you do our mid-morning or late morning update, you see that the probability shifted and the tornado actually fell very near peak probability. This is something that we're beginning to roll out internal to the Weather Service, at least initially. We have milestones to try to implement this sometime next year. We're working on getting some of the processing in the computer code working on the Weather Service's supercomputer to operationally harden and robust it, and then you'll begin to see some of this roll out to more of the public. And so again, trying to provide information in the watch, in between the watch and outlook timescales. You can do it not just necessarily for tornado, you can actually do it for all the individual hazards and see what the threat evolves in space and time, or excuse me, in time for the individual location. This is kind of an example of an internal web page that we've set up internal to the Weather Service to provide feedback. If you're a Weather Service meteorologist, you should have access to it. If you don't, please send me an email or contact me. We will make sure that you guys know where this is and how you can explore and utilize this kind of information as we continue to refine this before a much broader rollout in future years. So feedback is highly welcome on that. Using probabilistic information, as I mentioned, SPC also wants to start to provide potential translation of the forecast into impacts. We call this quantitative IDSS, where we're providing numbers to potential impacts. I'm not going to spend a whole lot of time on this. I've given several presentations over the years on what we're working on, but the idea is you can begin to provide probabilistic realizations, or you can create potential realizations using statistics and weather generators and probabilities, and begin to aggregate up what potential impacts may be. And so the idea is the forecast itself is the probabilistic risk at an individual location. But using quantitative IDSS methods, you can begin to aggregate that risk up over an area such that you can begin to say, this is the potential risk and exposure to, say, the state of Alabama, the state of Mississippi, and begin to know potential, to put some hard numbers to what some of the range of potential impacts may be. In order to do this, we've got to tap into the notion and recognize that not all tornadoes create equal damage. Basically, the longer a tornado is on the ground, the more opportunities it has to produce impacts to society, and stronger tornadoes are the ones that actually produce the longer path lengths. In fact, 50% of all F or EF tornadoes or stronger travel more than 20 miles. Compare that to an EF1 tornado, which travels on the order of 1 to 2 miles, is about the 50th percentile. The 50th percentile. So the takeaway is, if you really want to start to produce probabilistic impact and quantify potential impacts, you've really got to get an understanding of the potential intensity of the phenomenon. And for tornadoes, the tornado intensity is crucial for this modeling. So SPC began to look into it and explore, and what we found is, in our current forecast paradigm, there is implicit 4 different intensity forecasts. And I'm going to walk through what those are here real quick. If the SPC probabilistic forecast is no probabilities, that means that you are, the resulting, or excuse me, I should clarify. The forecast is not that there are no probabilities. The forecast is that the probabilities are less than 2%. It's a big difference there in terms of if no forecast means we don't expect any, less than 2%, there could be 1 or 2 tornadoes, but they're going to be extremely isolated in space. When that is the forecast, the resulting tornadoes that occur during that forecast period are usually very, very, very weak. And I should say that when we were doing this work, we used the initial 6Z forecast, so the forecast that was valid for the full 24-hour period. We have subsequently then looked at other periods, and so the figures that I'm showing here start with using the 1630. So when a less than 2% forecast is made, the resulting tornadoes tend to be very weak. The distribution of the intensity tends to favor the weaker tornadoes. If we make probabilistic forecasts or delineate areas greater than 2%, but we do not put a hatched area in other words, we are not explicitly forecasting significant tornadoes. This is what we call a non-hatched area. You see the resulting forecast tends to favor slightly stronger tornadoes, but overwhelming 66% of all tornadoes that occur in the resulting forecast, in the resulting time period, tends to be of the EF1 variety. And if you include the EF0, if you include EF1 or less, it's up, beginning to approach 90%. If we produce what we know as the significant forecast, or we include forecasts during the cool season, and the reason for that is in the cool season, because of the strong kinematic fields, you tend to favor slightly stronger tornadoes, but there may be fewer of them, and a current SPC forecast paradigm does not allow us to explicitly forecast a hatched or a significant area if we do not have an explicit unconditional 10% probability. So that's a limitation of our current methodology. But if you account for the wintertime tornadoes or the cool season tornadoes or summertime or warm season tornadoes when we have a hatched area, again, you see us begin to start to introduce the distribution changes to start to favor slightly stronger tornadoes. In fact, you go from 66 to 46% chance or probability of an EF0 tornado, assuming a tornado occurs, and you begin to favor some of these stronger tornadoes. Now, if you look at a double hatched area, and we define a double hatched area as basically a hatched area inside a high risk, the distribution actually shifts even further towards stronger tornadoes, where in fact the mode is no longer the EF0, but it's actually EF1. So as SPC forecasts begin to approach a high risk, what you see is the likelihood of a significant tornado begins to increase almost exponentially. And so implicit in our current paradigm, which is highly restrictive, we are actually providing intensity forecasts implicitly. And so one of the things that we want to do is we want to actually begin to think about how we can evolve our forecast paradigm at the SPC so that these intensity informations that we're currently implicitly forecasting, how can we make them explicit? And we're beginning some experiments and some work in the Hazardous weather testbed on how we might eventually evolve our convective outlooks to provide some of the intensity information explicitly. So I would encourage you, I believe those of you in the Weather Service, a call went out very recently to solicit input or participants for this year's Hazardous weather testbed. I would encourage you to participate and to fill that out if you want to be part of testing out how we might begin to explicitly predict the intensity of severe convective weather in addition to just the spatial coverage. For those of you who are non-government meteorologists, I believe that we will open up a call for participants sometime in February. All right, so I want to go back to this slide. I said that there was an information void between the outlooks and the watches, and SPC is actively working to try to improve our forecast such that we can produce more information in the void between outlook and watches. But realistically, there are two information voids in the current forecast and warning paradigm. There's one between the outlook and the watch, but there's another one between the watch and the warning. Often the watches are on the order of 4 to 6 hours or 4 to 7 hours, and warnings are on the scale of minutes. And so there's this gap in information. There's no official product filling the gap between the watch and the warning. And so this is a challenge for the Weather Service moving forward. And SPC has been dabbling in this area with what we call these meso-beta scale discussions, where we're essentially trying to identify corridors of increased or increasing intensity potential or coverage potential. And so I'm going to walk through some of what we did on March 3rd, 2019, where there was an EF4 tornado with 23 fatalities in Lee County, Alabama. And so as I mentioned, there's no explicit product designed to focus on the watch, between the watch and the warning. And so SPC has been using our Mesoscale discussions to try to identify and focus on these corridors of increased or increasing potential. Here's an example of the graphic early in the day on March 3rd. Here's another one where we're saying, hey, we're looking at the environment and trends suggest that this corridor is going to be of a heightened concern over the next the next few hours. Here's another one where we're saying the intensity and the potential is increasing in these areas. And then ultimately, what I kind of think is probably one of the best mesoscale discussions and attempts at identifying corridors of increasing potential that the Storm Prediction Center has ever had is this figure on the right. And what I've actually shown on the figure on the left is the same mesoscale discussion highlighted. And you can see a large number of the tornadoes that occurred on this date occurred in that mesoscale discussion where SPC was saying, here's a corridor along and south of the worm front where we're thinking that the tornado potential is going to be maximized over the next few hours. And so the idea is these meso-beta scale discussions where we're identifying corridors ultimately can then be fed back into the probabilities associated with the convective outlook, and we can do these increasing updates to the convective outlook to reflect the increasing potential in the nearer term. And then ultimately, I don't have a slide to say this, but just conceptually, you can imagine a scenario down the road where the delineation between the outlook and the watch becomes so blurred that the outlook and the watch are essentially one and the same, and that when the probabilities reach a certain threshold, you know that you've got to be of heightened concern. And what we traditionally think of as the watch essentially just becomes a societal product where it's a call to arms, and it's what triggers the emergency activation systems and the alerts. But everything about that watch is driven by these convective outlooks that are being updated and maybe even at an hourly time scale with the information where we're identifying some of these corridors. And so again, space between the watch and the warning, and then ultimately the watch and the outlook, and ultimately the watch and the warning, in a facets paradigm, it's going to become increasingly blurred. So much so, and then this is the next slide, SPC has also issued a handful of what we're calling meso-gamma scale discussions, where it's actually focused in on a single storm providing information about the intensity of the storm and potentially the intensity of the tornado within the storm. Now, the research that SPC has done suggests that providing this kind of information is possible now. You can combine environments and radar signatures to actually provide an estimate of say tornado intensity. So there's going to be an opportunity over the next few years for SPC and WFOs to work together on how to identify the best dissemination methods for some of this information. I'm not gonna sit here and say that maybe that SPC is ultimately the final home for this kind of product. You can make a strong case that it should be at the WFO level, and so that's something that needs to be discussed over the next few years, and how SPC can transition some of the work that we've done down to the local levels, including some of the tools that we've developed to the local offices. On how they can best utilize this for serving the IDSS needs of their core partners. And so this is going to be an area of a lot of discussion between SPC and WFOs over the next few years. I've had several discussions already with regions about moving down this path. And so here's an explicit opportunity where some of what's being done and the blurring of the timescales, whereas SPC is coming down to the 1 hour and the forecasters and the warnings are ultimately coming up toward the 1 hour or beyond, where we have an opportunity to partner together to provide the best service to our customers and partners. And so with that, I promised that I would leave some time for discussion and questions. And so I just want to say that SPC is embracing and moving towards facets now. We're tackling some of the gaps in the dissemination information that currently exists. I know that there's a lot of work going on also within the other aspects of the Weather Service Severe program, and in my discussions with some of the regions as part of some of the new working groups that exist within the Weather Service. we're tackling how best to move forward and develop a cohesive vision for how we want to implement facets into the severe weather paradigm. And so with that, that's all I have from a presentation point of view, but I'm certainly open to answering any questions and/or going back and talking in a little bit more detail if somebody wants some clarification about anything I may have shown today.
All right, thank you, Dr. Marsh. Fantastic presentation. I have a few questions, but I want to open it up to the floor. You can type them into the chat. You can also unmute yourself at any point. If you do it that way, please go ahead and identify who you are and what organization you're with. So we'll open up for a minute for questions from the floor, and then I have some after that. So. You shocked them all.
That, or they're furiously sending off emails to management demanding my mark.
Well, I'll start the conversation off. You know, from a WFO level and a new SUE myself, a lot of times I feel like the probabilistic is definitely the way the science is going and should go, but we often have this massive challenge of how to message some of this to the public, and the public seems to want this deterministic ones and zeros type answer, black and white. They don't want the 50%, you know. And so what are some strategies that we can use to kind of get that message out there? One thing I really like that you showed, and we struggle with, is when people hear there's a 15% chance of tornadoes, they say, oh, that's a very low percentage. But your graphic that had it on a kind of an hourly weather graph type thing with the color shading in the background, I think that color shading does add a nice way to get that across to the public that, hey, this is actually bad and you need to pay attention.
So there's a lot to unpack in your question, and it gets at the core of some of the questions that Facets is going to have to wrestle with. I try to, when I explain Facets to policy makers or decision makers, people outside the Weather Service, what I try to boil Facets down to is two fundamental tenets. The first one is meteorological information is inherently probabilistic and should remain as pure and tied to the probabilities as possible. However, information that's transmitted to society at large or decision makers is inherently societal. It's inherently, it's not meteorological, and therefore this is where we need to work with our social science partners in the community on how best to translate the probabilistic information into meaningful terminology and meaningful products for society. And so kind of the example using SPC is you can imagine that ultimately our outlooks and watches blur together and becomes this rapidly updating or continuously updating translating probabilistic grids. But that doesn't mean that we're going to be able to just switch to that and that's the end of it. We need to work with our partners on how best to then capture and create the societal product that is what we would traditionally think of as a tornado or a severe thunderstorm watch. That basically it goes back to the binary yes no. So meteorological information is going to be probabilistic, but not necessarily that's what goes to society. You can imagine society still getting a binary yes no type product, but that's where the work with social scientists are ultimately gonna have to come in. I'm not trained in how to do that, and the last thing I want to do is stay outside my lane. I got enough challenges just in the meteorology, and so I want to leverage the expertise of our social science partners. Now, to go back to what you mentioned about the 15% and the communicating that is a big challenge, and especially as you can imagine, we can have a 2% probability, and people are like, it's only a 2%. 2%? Oh, forget that. But if you think about it in terms of what is normal, a 2% in January in New England, you're probably 10, 100, 1,000 times more likely than climatology to have a tornado in your area. And so when you start thinking it that way, it's actually a big deal. You typically on the SPC space and time scales, the maximum probability of a tornado occurring within 25 miles of a point at any one location tends to be either May 15th in central Oklahoma, which is around a daily maximum probability of about 1.4%, or you can go up if you include the E of 0 tornadoes. I think there's a 1.6% up in northeast Colorado associated with the Denver cyclone. So if your maximum probability on any given day for any location peaks out at 1.6%, or to make the math easier, 1.5%. If SPC forecasts a moderate risk for tornadoes, or a 15%, we're essentially saying that you are 10 times more likely to see a tornado today than the maximum probability anywhere on any given day in the United States. When I start talking with people about that, they're like, oh. And so it's this notion of how best to communicate probabilities. I don't have a good answer for that. I don't know. I know it's cultural. We don't tend to think probabilities. I'm reminded of an anecdote I once heard about, at least for United States and Western society, we tend to think in terms of right and left. But there are cultures out there that if you tell someone to use their left hand, they don't know what you're referring to. They base everything on east and west, or north and south. And so what we would say is use your left hand. In their culture, in their society, they would say, well, use your east hand. And so this perspective, because we don't tend to think so much in probabilistic space and probabilistic rationale, we've got a lot of work on how to translate that into meaningful words and information for our partners and our customers and the broader publics at large. And so that's where beginning to explore multiple ways of communicating the same message in a consistent manner, but using different idioms and paradigms really comes into play. And again, not to harp on it, but to go back and reiterate, this is where interacting with our social sciences counterparts on how best to communicate the underlying threats and messaging is going to be crucial to our long-term success.
That's great. Yeah, I just got selected to do the HWT for the Severe Weather and Society dashboard, so I'm definitely looking forward to getting in with some of those social scientists and doing that. We did have a comment from Jacob, probably going to butcher the last name here. I'm going to go with Weiss. He said he liked the part about probability versus climatology. Now I think I understand probabilities. I think that is a great way to look at it as well, to kind of get that out. We also have a question from Keith Sherburne from NWS Rapid City. It says, hi Patrick, thanks for the talk. I applaud the SPC for its efforts trying to bridge the informational gaps that you referenced. In regards to the Mesoscale Discussions that SPC has relatively recently started to produce, what do you think is the added value of these products is when tornado warnings, including considerable or catastrophic damage tags, are already in effect? The information in both products would seemingly be very similar for our end users.
It's a good question. And ultimately what I would say is it may not necessarily be a value add to what you would see in the warning, but where the value add is not necessarily in the content, but in the reach and the audience that it reaches. The warnings may reach certain individuals, but then having the additional stuff coming from the Storm Prediction Center may draw additional focus on areas by your broadcast meteorologists or your emergency partners, or it's one of the things that you see in the social science literature is that people seek out confirmation, and so if they get the information about intense or catastrophic damage or tornadoes from a single source, and then they see the SPCs coming in all at the same time and reiterating that message, it may have potential value there in terms of evoking a response from end users. And so I wouldn't want to necessarily say that we're taking away or we're adding value to explicitly what the warning itself is doing. The added value comes in from the confirmation, so to speak. But he ultimately raises a good point. This is kind of what I alluded to in my last slide with this partnership. Maybe we will find out over the next 1 to 2 years that SPC is not the proper vehicle for this, and we develop a strategy and a plan moving forward where the tools and the stuff that we've developed transitions to the WFO, and maybe ultimately the end game is that this kind of information is added into a warning explicitly. And so rather than just saying catastrophic, we can actually provide numbers to the catastrophic as well. I'm not saying that is the ultimate end game, but what I'm saying is we're just now on the cusp of being able to do this. The research and the science are just now getting us there. And so SPC has this product that we can begin to utilize to explore how to do this, and maybe in the over the next 1 to 2 years we learn and we find out that it's actually better to get this into the warning. So what I would say is, in summary, the value add may not necessarily be in providing additional information. It provides a confirmation, so to speak, and then also 5–10 years down the road, SPC may not be doing the meso gamma. We may stay at the meso beta scale, and what you see here is a transition from SPC to the WFOs for this kind of information and these kinds of tools.
Yeah, it's good. I kind of look at it too, like we talk about this locally a lot with partners, of kind of having this ring of trusted sources that are all giving kind of the same message, where, you know, for instance, if somebody locally doesn't trust the government, but they do trust the local media person or the emergency manager, just having multiple people with the same message out just enhances our chance of getting that to the public, and also drowns out some of that other messaging that can be out there and can be erroneous at times. So, you know, I think there's definitely a place for it as well. I kind of want to go back to the beginning of your talk, because we here with the board recently, we've made it a point to kind of reach out to students more. I know there's some students on this webinar, and kind of get into the little bit about how people got into government and their current jobs and challenges they face going through school and things like that. So you had your picture of yourself in 11th grade there. What would you tell 11th grade Patrick Marsh today, with what you know now, about how to get to where you are?
Don't do it. No, that's a kind of a glib answer there. The real thing is, as a student, what I really wanted to do, and I would argue most people actually drive us to get into meteorology. You want to be part of you want to be part of the weather. You want to do the forecasting. No, not everyone, but most people, they want to be the forecaster. And what 3rd grade and 11th grade me thought was, the director of the Storm Prediction Center is the one who actually gets to make the final call. They're the one with the hot seat. They get to, we're going to go high risk today. We're going to do a PDS tornado watch. And as I got to SPC and I've gone through, I've spent 6–7 years here. Prior to that was at the NSSL, working closely with the Storm Prediction Center. What I have seen and what I have realized and what I would have told 11th grade me or 3rd grade me is, The director doesn't do that. Directors and managers are in budget meetings, they're doing planning, they're doing vision, they're doing personnel, they're doing, and I apologize, my computer just turned itself off, so you might have lost the screen. But directors, the directors and managers are doing more of the bureaucratic stuff. They are providing the avenue and the shield to let the forecasters do what they want. So what I would tell myself is, if you want to be the one on the hot seat making the decision about the forecast, you don't want to necessarily go into management. You want to be the lead forecaster. You want to study the weather. You want to be the best that you can possibly be at understanding the phenomenon. And to do that, there's no teacher like that of experience. So pay attention. Ask those who have gone before you. Shadow. Interact with them. Don't be shy. At least here at the Storm Prediction Center, and I would be willing to venture at most forecast offices, the senior people are more than willing to share what they know. So engage with them. Now, if you want to be the director, or you want to be a branch chief, or you want to be in management, the MIC, you want to focus on different things. You're not necessarily going to be the one doing the science and doing the forecast. You're going to be providing the space and the opportunity for the forecasters to be the best that they can be. And so one of the things that you need to focus on is communication skills, interpersonal skills, more of the soft skills, if you would. So take some classes in that. I really wish that I had done some of that. So you basically have to accept that you're not going to be the one that's going to get the credit for, or the phone call from the president for issuing the tornado warning for Greensburg. That's going to be the person, but you know that you're going to be the one that provides the space and the opportunity so that the forecaster knows that you have their back, and the confidence for them to do that, whether it's successful or if something goes wrong. So it's a little bit of a different mindset. I was a little naive in my 3rd grade and 11th grade answer. And so, but as I've gotten closer to achieving what you would say 3rd grade me's goal was, and I've learned this, I've moved and I've embraced the different roles. And so the advice I would give a student is be cognizant of what you ultimately really want. And that would be similar to the advice I would give to any weather service forecaster or any private sector forecaster that wants to think about embracing more management, is be open and have these discussions with your managers about what they actually do, because chances are it may be a little bit different than what you expected. At least that's what the case was for me.
Excellent, thank you for that. We did have another question come in from Edward Coran. At what point do you see the breakpoint evolving between SPC and WFOs in probabilistic space? That is, do you envision WFOs assuming more value-added content in local IDSS and less at the meso-E forecasting?
Next question. That's a really, really good question that I can offer speculation now, but that's all it would be, is it would be speculation. I don't necessarily know how all of this is going to play out, how Warn on Forecast is going to play out, what the role of DSS moving forward would be, what the structure of the Weather Service will be moving forward. But if I had to if I had to answer that question now, what I would say is WFOs inherently, by their nature and being closely tied to the population at risk, are going to be more tied to IDSS than SPC ever will. SPC is ultimately going to be in a support role for some of this DSS to the WFOs, but we are never going to be able to answer questions from every emergency manager in the country. I don't care what our staffing level looks like. So So there's always going to be this inherent tug in the IDSS paradigm for WFOs to do increasingly more. With that said, I don't see how you do proper IDSS without maintaining a proper situational awareness and understanding of the mesoscale evolution of the environment and the scenario that you may be facing. Generally speaking, I think a natural breakpoint, just because of how the warning paradigm is set up, is on the order of an hour. But knowing how warn-on forecast and the probabilistic hazard information or the fee concepts that might be applied to a warnings down the road, inevitably that's gonna expand up past an hour. And so SPC, even if we got the skill to be able to provide these hourly updates, and we come down to the hourly scale, I think you're going to see, at least in the 1 to 2 hour time period, substantial overlap. And that's kind of what we're going to have to wrestle with, and what the Weather Services and some of the STI portfolios within the Weather Service are going to have to talk about and address is, how do we bridge this gap? What are the swim lanes? What are the roles? How can national centers best support the mission of the local offices? Because frankly, in the current paradigm, if you take away the local offices and you take away the IDSS component of it, is there really a big need for what we're doing collectively with our forecasts? I think that's kind of the message that Louis is hammering home, is that the value that the Weather Service brings to this country and the force multipliers are actually the partnerships with the emergency management community, and so we really need that. So I don't see that going away, but I do believe that you've got to keep your toehold into the meteorology and in convective sense in the mesoscale space if you want to do proper IDSS. So that's a long-winded way of trying to run out the clock, because I don't have a good answer at this time, but I'm committed to having the dialogue and the discussion moving forward, because I think it's crucial.
Thank you so much. Well, we're past 12:05 here, so I think we're going to wrap up. But this was a really great webinar. It will live on further. We're going to, we record these, they go on YouTube. And so if you have anybody out there that you think this would be useful for, I know I myself would like to use it in our severe weather seasonal training, if that's okay with you.
Sounds good. And ultimately, if you want, we can reach out, and I'm happy to be a virtual participant in some of that. And that goes to anyone in the Weather Service. Myself, Bill Bunting, and everybody here at SPC, we're more than happy to be a part of any training or webinars or anything that you might want at the local level. So we're a resource here. We want to be a community resource. Feel free to lean on us. And we're not there yet with fire, but don't worry. SPC is wanting to also do similar things for the field and the community in fire, and so hopefully we'll start rolling out some forecast tools for that in the near future as well.
Excellent. Well, great discussion. Like I said, this will be available on YouTube once I get it downloaded and edited and things like that. And so we'll have that up on our AMS BOGM YouTube channel. We'll also post links to it on our Facebook and Twitter pages. Patrick, I'll let you know personally when that's available. And then, you know, to keep looking at our Facebook and Twitter for our next series of talks coming up. We've got some great ones on the way. So thanks so much, and hope everybody has a great rest of their Wednesday.
Thanks for having me. And again, just to reiterate, if we can be of help to anyone out there, please let us know. So thanks for having us.
All right, thanks so much. Take care, everybody. Have a great day.